Hi, Sterling Allan here, PESN. Just wanted to give you a quick synopsis of the experiment that we ran on May 1st. Today is May 2nd. It's past 6 o'clock in the evening. I've just been doing some ohm measurements. I'm going to empty the water bath, take measurements of the water to make sure, just double check. I think I may have added one extra 2 liters without accounting for it, so I'm just going to double check my measurements on the water bath by emptying the water into this bucket using a graduated or a beaker. I've got a 100 milliliter beaker or 1,000 milliliter, 1 liter, and I'll just empty it into that bucket, throw the water outside, and here's our setup. The idea again is the Brown's gas. You take DC electric current from a car battery, and this is just a electrolysis plate. You've got alternating positive, negative, positive, negative, positive, negative. So the positive terminals here, negative terminals here. You see it goes every other one. And we were putting power in from the battery charger. We had a rheostat, an AC rheostat, AC in, AC out. You can turn it up and down. 10 is full. And we were able to regulate the power that way. And you make through electrolysis, you make Brown's gas, which is hydrogen, oxygen, and other cool stuff going on. Up into the tubing, the water comes down through here, up through here, bubbles through the reservoir. It comes out, the gas comes out through here into the bubbler, and out from the bubbler, the second bubbler, into, we had these hooked up. This is a flashback arrestor going into the catalytic converter. And in the catalytic converter, first of all, there's these fins here to, in case we had any heat on this end, to pull off the heat. And then we had ceramic insulation up here, and as the gas goes across the catalytic converter, the 4 inches of the catalytic converter here in this chamber, it would react and go back to water, and possibly some other stuff going on as well. And then it drains into the bottom, and we have a plastic bottle with a cap on it with a tight fitting of a hose that goes out, so we were able to measure any outgoing gases, and this bag stayed flat the whole time. There was no outgoing gas. There's a little bit of water in the bottom. We'll be looking at that in a minute. I'll take it out of the water bath. And so the ceramic insulation at the top is to insulate the heat of the catalytic converter from the incoming gas, so you don't get flashback. And then the amount of heat that we were getting, we were getting anomalous heat, more than what classical physics would say is 64% efficient, with 75% efficient is about the max you can get on an electrolysis unit, and catalysis you can get maybe 85%, taking the water back to, or the gas back to water. Multiply that together, that 64% is the max efficiency you could get scientifically, and we measured 77% efficient heating the water versus the electricity going in, converting those to joules, 77%, and that's still not taking into account the water losses from the water bath into the environment. We had it insulated pretty good with this this insulation, and we had this pad on the top, a couch cushion on top of a cardboard, and we also had packing peanuts sitting on top of the water. You still see there's one packing peanut. There's about 4 inches of packing peanuts on top there. Here's our bag of packing peanuts right there that I took off so that I can take the water measurement of how much, just double check my water there. We're going to be measuring the outflow water. We put in a little bit ago, I took a note of the video, we measured how much water we used in the reservoir, and we went from this mark down to this mark. And by the time it stops bubbling, it goes down to that mark. So I went with the lower mark up to there, and I refilled it back up, and we measured, I think it was like 213 milliliters of water that we put in. And now we're going to see how much water we got out at the bottom. We'll just unscrew that cap and let the water drain out into this graduated cylinder. It should fit in here because this is a 250 milliliter graduated cylinder, and we only put 213 in on the reservoir. So last time we only 21% of the water that we put in via the reservoir ended up in the catalytic converter. This has stayed at this position. This is the position it was in during the experimentation. I haven't moved it. Of course, it's going to be jostled a little bit when we stir the water. I use this stick right here to stir the water. We would just come in. We had the insulation on top. We'd come in and wiggle that back and forth about like that for at least a minute. And of course, the packing peanuts were on top, but we could stick the stick through the packing peanuts and just stirred the water for at least a minute, rigorously like this. And so we were, otherwise you got the hot on the top, cold on the bottom. And I would have the thermometer here, just grab the string and liberate the thermometer, and it would come up, and I would measure the, right now it's at 21.9, I'd say. And then I had an ambient thermometer right here, the same make and model, but it's not calibrated exactly the same. We've been calibrating them, taking their measurements at the same temperature, and we just read that on the table here, and that one would be 20. I'd say 20.3. And then I record it in our data log, manually recording, just writing it down. We don't have any electronic data logger stuff, so just manually writing it down. So we'd had each measurement, each time I would take like at 8:24. This is the last measurement we took at 9:21. We took the Celsius temperature of ambient. There's this thing right here is just an electronic. It has outdoor, indoor, and we have the probe, this electronic probe going down. See the wire here goes down, sitting in the bottom of the tub over there. And so that was this reading right here, 70.5 F, 65.5. So right now, indoor temperature is actually lower than, the room temperature is lower, and it's going to want to be pulling the temperature down on the bath. I should take another reading, because the last reading I took, the ambient was still above, according to this anyway. These are not accurate. We've been calibrating, taking measurements at the same temperature we've got like 4 thermometers involved. So anyway, that was the OD, is what I'm calling outdoor. And then we had an infrared. This thing's not very accurate either. Just, hit the 65.8. Right, we record that. That's the IR for infrared. And so we had for ambient and bath. The idea with the infrared on the water bath was that we had a little, where'd he go? I guess he put it back. He had a PVC pipe that we were putting right through here so that you could read the wall of the water bath. But the reflection, I guess, on that shiny surface just did not work, and it was reading the same the entire time. It wasn't not moving up, so we're going to have to discard that one. That's not going to be helpful. But this reading is plus or minus 0.5. It goes 0.0, 0.5, then goes up to the next measurement. Plus or minus 0.5 Fahrenheit. And then the next reading we took was, I measured with the infrared thermometer, I measured the temperature of the HHO generator and the reservoir. And then I said balloon. We were going to use, sorry, my battery just died. I had to replace that out. look at this bag. It's not inflated at all. It's empty. That's for the whole experiment. No escaping gas. And we had that fastened on with a really tight rubber band. We broke a rubber band, wrapped it around really tight, and then tied it in a knot around the end. We had a fitting that Daryl Jacobson had, and there's no gas coming out. It's not quite vacated, but it's pretty. That it wasn't any fuller than that when I put it on. I mean, that's what it was. I emptied it out and we slipped it on and fully vacated, and it didn't move. So anyway, what I was saying is we took. That's what the balloon temperature was. We were expecting that if we got any gas in there, that it would be interesting to know what temperature it was, and so that was going to be the temperature of the balloon. But that was always at ambient the whole duration. And then we had a kilowatt meter on the wall. It's out in the car right now, but it was plugged into this outlet right here. And so we were able to read the volts times amps measured by the kilowatt meter. And you'll see that those started dropping here at the end, and that's why we stopped the experiment. It was sticking here. We started right here, and you see the readings 405, 410, 409. They were around 400, and then here they started dropping a bit. And I didn't want to have to worry about, doing the area under the curve. I wanted to just get a good average on the volts. And then I took an amperage and voltage reading. We had a clamp-on amp meter of my dad's. This guy right here was hooked onto the DC power going to the battery. Going to the HHO generator from the battery charger. And then we had a voltmeter hooked onto the positive and negative terminals of the Brown's gas generator. And that was this meter right here that we're doing the ohms on right now. And so those are all the measurements we took each time. See what else that I need to mention. We have the water bath sitting on foam, styrofoam, in addition to this R19 insulation, wall insulation. So we had it pretty well insulated. Then, let's see here, what else should I mention? I should mention today, in another video we're going to have up, the reason for this tripod setup. See if I can get my camera over here. Just a second. Got a 100 milliliter beaker, or 1,000 milliliter. 1 liter, and I'll just empty it into that bucket, throw the water outside, and here's our setup. The idea again is the Brown's gas. You take DC measurements of the water to make sure, just double check. I think I may have added 1 extra 2 liters without accounting for it, so I'm just going to double check my measurements on the water bath by emptying the water into this bucket using a graduated, or a beaker. I've got. Hi, Sterling Allan here, PESN. Just wanted to give you a quick synopsis of the experiment that we ran on May 1st. Today is May 2nd. It's past 6 o'clock in the evening. I've just been doing some ohm measurements. I'm going to empty the water bath. We were putting power in from the battery charger. We had a rheostat, an AC rheostat, AC in, AC out. You can turn it up and down. 10 is full, and we were able to regulate the power that way. And you make electric current from a car battery, and this is just an electrolysis plate. You've got alternating positive, negative, positive, negative, positive, negative. So the positive terminals here, negative terminals here. You see it goes every other one. And